In the philosophy of science, models of scientific inquiry have two functions: first, to provide a descriptive account of how scientific inquiry is carried out in practice, and second, to provide an explanatory account of why scientific inquiry succeeds as well as it appears to do in arriving at genuine knowledge. The search for scientific knowledge extends far back into antiquity. At some point in the past, at least by the time of Aristotle, philosophers recognized that a fundamental distinction should be drawn between two kinds of scientific knowledge roughly, knowledge that and knowledge why. It is one thing to know that each planet periodically reverses the direction of its motion with respect to the background of fixed stars. It is quite a different matter to know why. Knowledge of the former type is descriptive. Knowledge of the latter type is explanatory. It is explanatory knowledge that provides scientific understanding of the world. Accounts of scientific inquiry. Classical model. The classical model of scientific inquiry derives from Aristotle, who distinguished the forms of approximate and exact reasoning, set out the threefold scheme of abductive, deductive, and inductive inference, and also treated the compound forms such as reasoning by analogy. Pragmatic model. Logical empiricism. Wesley Salmon began his historical survey of scientific explanation with what he called the received view, as it was received from Hempel and Oppenheim in the years beginning with their studies in the logic of explanation and culminating in Hempel's aspects of scientific explanation. Salmon summed up his analysis of these developments by means of the following table. In this classification, a deductive nomological explanation of an occurrence is a valid deduction whose conclusion states that the outcome to be explained did in fact occur. The deductive argument is called an explanation, its premises are called the explainans and the conclusion is called the explanandum. Depending on a number of additional qualifications, an explanation may be ranked on a scale from potential to true. Not all explanations in science are of the DN type, however. An inductive statistical explanation accounts for an occurrence by subsuming it under statistical laws, rather than categorical or universal laws, and the mode of subsumption is itself inductive instead of deductive. The DN type can be seen as a limiting case of the more general IS type, the measure of certainty involved being complete, or probability 1, in the former case, whereas it is less than complete, probability.